Hello fellow AGD coders, and welcome to another video. It's been a little while. Hope you're all doing well. I've been fairly busy, but here I am back with a very short video where I'm going to be showing you just a little bit of an introduction to how AGD uses memory on the Spectrum, and this is going to be a lead up to how we can then add an attribute buffer, which I've shown on the Facebook page. But before I do that, I thought it would be good to show you roughly how AGD memory works and why there isn't so much of it and how we can sort of make the most of it. So as you can see here, I've got a little diagram for you, and obviously below 16K we've got the Spectrum ROM, and then above that, as you can see, we've got here, as you will know, most of you will know about the Spectrum memory, we've got the screen pixels, the screen attributes here, and just above that we've got printer buffer and reserved area. So this part of the memory here is fixed, and we can't change any of that at all. Now the rest of it is used by AGD. Now this is just a rough guide, this isn't exact, so don't use these addresses as being absolute, but the AGD editor starts at 24,000, and there is approximately 6K which is used by the editor for the various routines, and some of these are actually paged in from higher memory, from the 128K banks. So this area here basically is not available to us either. However, switching over to the editorless version, there is the potential in the future for us to compile the game lower down in memory at 24,000, and we could get this 6K here possibly back, so we may have an extra 6K to work with once we have the editor outside of the Spectrum itself. So that's that part of it. Then if we move down, again, these are just rough guides, they're not absolutes, but the next thing we have is about 7K from roughly 30,000, and this part holds the font, the game variables, and a lot of the game engine here. So this is the part that makes the game run. It will be the various routines that move the sprites and check the blocks and do all of that nice stuff. And then beyond that, at here 37,000 roughly again is where the game data is stored. So this is your personal data, as in your scripts, your sprites, and your messages and everything else. And that's why, as you can see here, the size of it is just under 28K, which you'll know is the amount of space that you have to work with roughly with AGD. And then finally here at the very top of memory we have a 768 byte block buffer, and this is used by AGD to store a copy of the current screen in terms of its layout, in terms of the different types of blocks that are used. And as you can see, of course, it matches exactly here the screen attribute, because there are exactly 32 by 24 blocks on the screen. So this tells AGD which blocks are walls, which are custom, deadly, and so on. And obviously then it loads in that data per screen, and the engine will then respond to that accordingly. So yeah, that's pretty much how the memory works. I know some of you might think, well, perhaps I could have a smaller buffer here if my screen is smaller. Well, perhaps you could, but AGD is not a bespoke game. It's an off-the-peg game. Obviously it has to cater for every possibility, and so if you want to use full screen, you obviously need that. There are some things we can do potentially to save some space there, but not without getting quite technical. So really there isn't so much we can do to save much memory there. We've got about 30K. If you're efficient, if you're careful, you can write a good game. Many people have, of course. And so yeah, anyway, that's pretty much it. What I'm going to do in the next video hopefully is show you how to create an attribute buffer, which is going to allow us to be a little bit more playful with colors. And we can do certain effects and color the sprites and various things like that. We'll be taking a copy not of the block types but of the block colors, and again it will take up about 768 bytes, but the effects that you can get if you want those kind of things in your game probably a fair trade-off because 700, 800 bytes is not a huge amount, and we can get some pretty nice effects by doing that. Okay, so that's the end of the video. Take good care, and as always, happy coding. Thanks, bye.